In this week's lecture, we're going to start to make our programs a little bit more intelligent. We're going to talk about how we can have programs that make decisions. And we're going to look at the syntax and all of the different items involved with computers making decisions and writing instructions so that computers can make those decisions. The first thing we need to discuss is a new data type. Last week we talked about strings, floats or doubles, and integers. This week we want to talk about the Boolean data type. A Boolean is a special data type where the values can only be true or false. There are no other options. There are only two values available in the Boolean data type. In some programming languages, you'll note that instead of true and false, you'll see yes and no, 0 and 1. But in this specific case, we're going to be using true and false. I also want to point out that true and false are keywords of our programming environment. These are not strings. There are no double quotes around true or false. So when you start to see the programming examples later on, please note that true and false are their own values within our programming environment. So having the ability to create variables that store data of type Boolean, either true or false, we have this ability now to start thinking about how we can make decisions in our programs. So to make decisions in our programs, we want to ask a question. And we're going to write code that asks a question, and that question will then evaluate to a Boolean value. So it'll evaluate to true or false. So we're going to ask a question and get an answer. We're going to call these questions conditions. So let's talk a little bit about how this process works. We basically want to create specific questions, and based upon how those questions are answered, we want to perform some action. So if this question is true, do this. If this question is false, do this other thing. Otherwise, do something else. This is a pretty important slide because we want to think about how we're going to write code based upon the answer to the given question. So if the answer to our question is true, then we're going to perform some action. If the answer to our question is false, we may perform another action. Sometimes, regardless of the answer being true or false, we may want to execute some type of default action. So this is kind of a really nice synopsis of what we're going to be doing when it comes to writing code. So how do we ask these questions? How do we phrase these questions in code? Well, just like last week we looked at mathematical operators, right? And we learned some new ones. This week we need to look at relational operators. And these are operators within our environment, visual logic, that let us phrase or ask questions in our code. So these allow us to define conditions. And we'll be able to see if two values are equal to each other, if two values are not equal to each other, if one value is greater than another, or one value is less than another, or if one value is greater than or equal to another, or one value is less than or equal to. These are going to be the operators that we'll use to phrase our questions. So let's take a look at some examples of conditions. I'll first write the question in English, and then we'll look at how that might translate to code. So let's say we wanted to write a condition that said, are you old enough to vote? And so our goal here is to think, okay, well, if you're old enough to vote, what does that mean? Well, it means that you're probably older than, you're currently 18 or older. So let's see how that might work. So if we have our age currently stored in a variable, we could say, is age greater than or equal to 18? And if this is true, if the user or the value stored in age is 18, 19, 20, then this would evaluate to true. The answer to this question would be yes. If the answer stored in age was 16, then the answer to this question would be no or false, and we could take action based upon that. Okay, either allow the person to vote or not allow them to vote, or register them or whatever. Next up, can I buy this? Let's say you're at the store, or you want to make a credit card charge or a debit card charge or something, you want to buy something. So can I buy this? Well, let's say in one variable we have the price of the item that we want to buy, and then in another variable we have the amount of money available to us in our wallet or bank account. And we would say, hey, look, if the price of the item we want to buy is less than or equal to the money in wallet, then true, yes, we can buy this thing. If I don't have enough money in my wallet, then false, I cannot buy this thing. So we would phrase this as saying, is the price of the item less than or equal to the money in our wallet? Only talk to people not named Jason. This isn't really a question, it's more of a statement, but let's say I want to write code and that code will only say hello to people whose name is not Jason. So really there's an implied question here. Is your name Jason? Yes or no? And so for this statement to work, we would need to figure out if my name is or isn't Jason. And the way we would ask that question is we would say name does not equal Jason. And you'll note that in visual logic, the not equal operator is less than, greater than with no space right up next to each other. When we get to Python or when you get to other programming languages, this is a pretty uncommon operator. You'll see that it's probably an exclamation point followed by an equal sign. But in visual logic, we use this this thing that looks like a diamond. So this basically says, does your name not equal Jason? And this is kind of weird, right? So any name that's not Jason, this would say, yes, true. And any name that is Jason, this would say false, right? Because this is a not operator. We're using backwards logic here. One thing to point out, and why I'm even having a little bit of a hard time explaining this, is negative logic is hard, right? It's not hard to not use negative logic. You're like, well, wait, what does that mean, dude? We always want to try to phrase our questions in the affirmative. So I put this example in here just to kind of prove that we can end up having some weird twisty logic happen to us if we start to use negative logic. But sometimes the not operator is helpful. We want to ask a question. Are you not Jason? One thing to note is that computers can only answer one question at a time. So when we want to answer a complex question, we're going to need to think of how we can break that complex question down into a lot of little questions. Okay, so we're going to need to use multiple conditions to evaluate our complex questions. So any question that's more complicated, think about something like, should I take an umbrella today? Yes or no? And you think, okay, well, that's a simple question, but not really. You might think, well, is it raining now? Yes or no? Will it be raining later? Yes or no? Will I be walking outside? Yes or no? Do I have to wear nice clothes today, or do I not care about what I'm wearing? Yes or no? So even something simple like, should I take an umbrella today, could turn out to be a really complex question, or it's a really simple question, but might require a lot of complex logic behind it to make sure that we're making a good response. So it's important that we note that when we want to ask complex questions, we're going to need to think about how to break those questions down into smaller questions. And we'll have two approaches to doing this. We'll either be able to nest statements, in other words, put one question inside of another, or we'll be able to combine them into compound conditions. One thing you'll know is that programmers like shortcuts. So in many cases, what we're going to end up doing is you'll see there'll be one way to do something, and then later on we'll talk about another way to do the exact same thing. And in reality, there's going to be more than one way to solve any problem in a program. So how you might come up to a solution might be different than how someone else comes up with a solution. And that's great. That's okay. Our goal here is working code. So it's completely possible for two people to have the absolute correct output and correct functioning program, but take different approaches to it. So in addition to our relational operators discussed before, we're also going to have compound logical operators. And so these will be not, and, or, and XOR. And we'll talk about what these specifically mean when we get to the code examples a little bit later in the lecture. But these are going to allow us to ask two questions at one time. Is the person greater than or equal to 18, and are they a resident of the county in which they wish to vote? Those are two questions, and we could either use two independent if statements or conditional statements to answer that, or we could use the AND compound logical operator to ask that in one compound question. So just like we can have compound sentences, we can have compound conditionals. And one thing you'll note when we use these a little bit later on in the code is that when we do use these logical operators, we really should put the conditions, since we're going to have multiple conditions chained together by these operators, in parentheses so it becomes easier to read. Let's talk quickly about errors, because last week we just kind of dove right in, and I'm sure a lot of you made mistakes, and in fact you should make lots of mistakes, right? Learning to code is a lot like playing a video game. You have lots of opportunity to fail and retry, and you shouldn't be afraid to, if you don't get something on the first try. I often tell students, if you get something right the first time, you should be worried, because that's really strange in programming. It's a good chance you miss something. So I'm always more scared when I get something right on my first try than if it takes me a few tries. You may have logic errors in your program. This is a case where your program runs, but we get unexpected output. And this is because the flow or path that our program is following is wrong. So this is something that may come into play this week with conditional statements. A good example would be saying, are you 18, and determining if a user can register to vote. But then your program still allows someone who's under 18 to register to vote. That's an example of a logic error. It's not enforcing the rules as are expected. Or if you go to the ATM machine and you try to withdraw $20 and it gives you $200, that would be a logic error. Everything worked, it just didn't work properly. Next up are syntax errors. These are probably the most common things that you made last week and will make throughout the semester. But basically, this is where you failed to follow the rules of the programming language and its syntax, and the program will refuse to run. So a syntax error will be something like leaving out an ampersand when concatenating a sentence, or forgetting to use two double quotes around a string, maybe just putting the first one and forgetting the second one. And this is that condition in visual logic where you end up with the big red error window. And so you got to go back and make sure that you're complying with the rules of the language. And then finally, there's a runtime error where the program works correctly. It runs, so you're complying with the syntax of the language. Everything is logically correct. But for some reason, at some point in your program, it crashes. So you're just kind of executing. It asks you to enter a number, and then the program crashes. A runtime error is something that happens when your program is running, and at execution time, at some point, it just bombs out on you. So these are the three different types of errors that you'll probably run into, and it's important that we run our code and test thoroughly to make sure that we're not making any of these errors. And if you have questions, these are great things to ask about on the course discussion board. So let's take a look at how this works in visual logic using one of my previous examples. So right now I have an input set up, and this input is going to ask me to enter my age. And what I'd like to do is utilize the value stored in this variable so I can make a decision. So I'm going to come down here after the user has entered their age. I'm going to right click in this area, and I'm going to choose an if condition. In visual logic, if conditions are represented by diamonds, and the diamond will show us two specific branches. We're going to have our question inside of the diamond. That'll be our condition statement. If that condition evaluates to true, if the answer is yes, it'll go to the right and execute the code on the right. If the condition is false, or the answer is no, it'll go and execute the code on the left. So our code is now branching. We can now go in different directions based upon different values. So let's go ahead and write this condition. And this is the one we saw previously in the presentation. So what I'm going to say is, if age is greater than or equal to 18, this is how I can ask this question. If you want, you can wrap your conditional in parentheses. It's not required when there's only one condition, but sometimes it can make things be a little bit more readable as well. I'm not going to do that for right now. We'll see that in a future example. So let me hit OK. And now what I want to do is I can run this. And if the user enters an age that's greater than or equal to 18, it'll go to the right. But we won't see any output. So let's try to make this a little bit more helpful. And so what I'll put in here is you can vote. And notice that I don't have to have anything on the other side of this conditional statement. In other words, if I want to output you can vote when the user is greater than or equal to 18, in other words, when this answer is true, then I put that print statement over here. If I don't want to do anything if the user is too young to vote, I can just leave this side blank. I don't need to have something on both sides of this conditional operator. So let's run this and see what happens. So I'm going to first enter my age, and I will enter it as 20, and then hit OK, because I am totally 20 years old. And it's going to say, hey, you can vote. Input the value, store it in the variable age, come down here, notice that the value stored in age 20 is greater than or equal to 18, and then go to the right and output the code. Let's run this again, and this time I'll say that I am 16, and 16, notice nothing happens. Why? Because 16 is not greater than or equal to 18. It's actually less than, correct? So this is false or no, and it goes to the left. And if you want, we can put an output statement in there and say, how about you cannot yet vote. And things are getting a little big here on the screen, so let's back this out. And what you'll note is now if I run this and I put 16 in again, we're going to branch to the left. Oops. We'll say you cannot yet vote. So that is the specific case. These little windows sometimes get rough to deal with. And when I hit OK, we'll come down here and go to the end. Now let's look at how we can make a compound conditional using this program and kind of expand on the question that we want to ask. So not only do we want to see if this person is older than 18 to vote, maybe we also want to ask them if they're a resident of the current county, whatever that county might be. This might not logically be the best program. So let's first look at how we can utilize a nested conditional. First thing we want to do is verify your age. Yep, you're older than 18. And then I'm going to go ahead and if you are older than 18, I'm going to put another condition in here. And what I want to do is say, well, look, let's say that, if you're a resident of the county, then you can vote. Well, first thing we have to do is ask the user if they're a resident. So we're going to set up a variable called isResident, and we'll just say, enter y if resident or n if not. I realize that doesn't make the most sense in terms of the program flow, but it's what we're going to use. So what's going to happen here is that the user is going to input their age. If they are older than or equal to 18, we're going to come down here, and then we're going to ask them if they're a resident. And then we're going to ask another question. And that question is going to be if resident is resident equals capital Y. So if the user enters the capital string Y, then they can vote. And we'll hit OK. And actually, we can move this output into that true block. And you'll notice that this program's starting to get a little big here on screen. And it's not going to be uncommon for our programs to get really large moving forward. So just keep that in mind. And now what we want to do is, in other cases, if maybe they are 18, but they also can't vote. So what I'm going to do is add another output here and put, sorry, only residents can vote. We'll hit OK. So this idea here is that we're going to have two decisions. So to be able to vote, you have to be older than 18. Yes, that's true. We'll go this way. And you have to be a resident. It doesn't make sense to ask if somebody's a resident unless they're old enough to vote. So it kind of makes sense that we defer this decision till later on in the program. And in this specific case, we know right away if they're not old enough, they can't vote. But if they are old enough and they're not a resident of this county, then they can't vote as well. So it depends on how that's set up. So let's run it and see how it works. So we'll enter our age, and we'll say that we're 18. Okay, and if we're a resident of the county or wherever the voting is happening, the condominium complex, wherever you might need to be a resident to be able to vote, enter Y if resident or N if not, and you'll note that it says we can vote because, I was 18 and the value entered by the user is Y, and it came down here and said we could vote. If we run this again, and I choose something else. Notice, by the way, I don't have to enter N for no. So let's say if I'm 18 again, and it says enter Y if resident or N if not, I can enter anything there if I enter Jason, right? It'll still go the false because the only way it's going to the right is if this equals Y. So it'll say, sorry, only residents can vote because I entered something that was not capital Y. What happens if I enter lowercase y? Well, let's do this again. And we'll enter lowercase y. And one of the things you'll note is that, sorry, only residents can vote Y because lowercase y is different from uppercase y. How could we fix that? Well, we could set up another nested conditional, but let's set this up to use a compound conditional. So what I'm going to do is, first things first, is wrap this in parentheses. And I really want to ask two questions. The question I want to ask is, did the user enter a capital Y or a lowercase y? That's 2 questions. And you'll notice I even said the word in there. Did they enter a capital Y or a lowercase y? And so an OR compound conditional statement, this logical operator will return true if either one of these is true. If the user entered lowercase y or they entered uppercase y, if either one of these items is true, we'll go down the true path. So now let's run this and see how that works. So now we're going to say we're old enough to vote again. And now this time I'll enter lowercase y. Oops, that was capital Y. Caps lock is on. And it says I can vote. Why? Because I entered capital Y or I entered lowercase y. So in this specific case, it's kind of nice to have this ability to set up a compound conditional so that we can go through this branch to see if a person is eligible to vote. So this is a really basic introduction to the concept of nested conditionals and to the concept of compound conditionals. If you want to take some time to learn more about how the logical operators work, you can set up an output statement in Visual Logic and build some custom output to explore these. In Visual Logic, you can just type true in, and note there's no double quotes around that because that is the Boolean value true, and if I run this, it's just going to print true. And so I can come in here, and if you want to see how these things work, not true, and oops, we'll keep caps lock on, not false, and we'll hit OK. And if I run this, what do we get for output? I get the opposite. So why? What is the opposite of true? False. What is the opposite of false? True. So you can see how the not operator works in that case. And so what I would recommend that you do is go through and build some outputs so that you can test each one of these logical operators. And so let's start with true and true, true and false, false and true, false and false. All of these are going to be operations or conditionals, and each one of these is going to evaluate to a value. So let's see how this works out. I'm going to run this program. We'll skip the first block. We've already seen how that works. And now let's compare this to what just was written here. So what you'll note is true and true. If this is true and that is true, the entire expression evaluated to true. With the AND operator, it's pretty, once you think about it, for this entire expression to be true, both sides have to be true. If you are 18 and a resident is the only way you can vote. So for an expression using the AND logical compound operator to be true, both sides of the equation, or both sides of the conditional, have to be true. So you'll note that if something is true and something is false, the whole statement is false. If something is false and something is true, the whole statement is false. If both items are false, the whole statement is false. So you can see how this operates. Let's do this again, and I'll do this one up top with OR. And in fact, the easiest way to do this is going to be to copy this, and we'll just paste it up here. And we'll change all the ANDs. Oops. And I keep forgetting I have caps lock on. And change these to OR. And see how this works. And you'll note that this time around, when I hit run, we'll see, oops, that I have a syntax error because I have a space in there that I forgot to get out. And now if I run it, that syntax error is corrected. We can note that true and true is true, true or false is false, false or true is false. The only time when you use the OR operator that an entire compound conditional evaluates to false is if both sides are false. Because say if this is true or that is true, then everything is true. If this is true or that is false, well, when in an OR condition, you only need one of the items to be true for the whole thing to be true. If you're 18 or if you're a resident of this condominium complex, then you can vote. That'd be kind of odd, but if you want anybody in the township who's 18 or is a resident to vote, that would allow it to work that way. So in this specific situation, we can explore how these work. By the way, you can make these as long as you want, right? There's no rule that says this only has to be compound to 2 items, right? You can string these together in as long of a conditional statement as you'd like. The only real limit is what your brain can comprehend. And notice, because all of those in that top statement were true, or this is or, I only need one of those items to be true for that entire specific statement to be true. So what I'd recommend is take a look at this portion of the chapter and maybe set up a table similar to this in Visual Logic and take a look at how you can utilize these compound conditionals to make your code more readable. Again, at the end of the day, code that's readable is our ultimate goal. So if you're not comfortable with compound conditionals, then focus on using nested conditionals.